Hey everyone, welcome to our first lesson of physics, where we're going to do a little bit of math review. So this is our math review lesson. So physics has three fundamental units: length, which is in the meter; mass, which is in kilograms; time, which is in seconds; and then the symbols are all small letters: m, kg, and seconds. So these are our three fundamental units, and these are the ones that we're going to try to use the most. There are a few exceptions to using these, but these are the ones that we're going to use the most in physics. So what we're going to talk about is significant digits, or Sig Digs if you're cool. The rule that works with Sig Digs is to always start counting when you see the first non-zero number. So that doesn't make a lot of sense until we actually try some examples. So how many Sig Digs do the following have? Well, let's see here. We have, this is our first number, right? And it's a non-zero number. So we start counting. So we have 1, 2, 3 Sig Digs. So this has 3 Sig Digs. And then for this one, zero number, zero number, zero number, zero number. So none of these are significant. And then we see our first non-zero number, and we just count after that. That's all. So this has 2 Sig Digs. Okay, so these are board questions. Usually when I would be in class, I would have a whiteboard that students do them on, but this is a chance for you to pause the video and try them on your own and see if you can get them, and I'll go through them now. So pause the video and see if you can get them. Okay, so how many Sig Digs do the following numbers have? Non-zero numbers, so we have 1, 2, 3, 4. Okay, non-zero numbers, so we have 1, 2, 3, 4, 5. You'll have to excuse my mouse. It does that sometimes where it sort of shoots to the left. I don't know how to fix it. I switched my mouse. I got a new mouse pad, but it's going to do that sometimes. So just ignore that. So this has 5 Sig Digs. Okay, 0, 0, we don't include it. So this has 2 Sig Digs. Okay, and that's how you do Sig Digs. So why do we use Sig Digs? Well, significant digits are based on the accuracy of our measuring tools. Whenever you're doing stuff in physics, you're always measuring it. You're measuring speeds, you're measuring distances, you're measuring times. So using this ruler, how many Sig Digs can we get? Well, so say if I put a line right there, right? So if we wanted to say where this was, it's definitely 3. And then we have 1, 2, 3. Ooh, it's hard to read that. 1, 2, 3, right? So we can definitely say it's 3.3. And the last one we can estimate, which is in between these. And I'd say it's probably 5. It's probably right in the middle there. So I can say that with a certain degree of accuracy that this is 3.35 centimeters. Okay, so I can be good to 3 Sig Digs. But then if we had another ruler that looked like that, well, I know it's 3 for sure, and it's a little bit more than 3, so maybe I can say this is 3.3. That's what I would estimate that in between. So with this ruler, because we don't have those in-between lines, we can only be good to 2 Sig Digs. Okay, so that's why we use Sig Digs, is if I measured a whole bunch in this ruler, and then I measured one in this ruler, well, we're only as accurate as our least accurate measuring device, so I could only give my answer to 2 Sig Digs. So there's some rules with multiplying and dividing Sig Digs. When multiplying or dividing using Sig Digs, you round to the number with the fewest Sig Digs. Okay, so I have this question here. So if I want to go 2.25 times 1.5, well, if I type this into my calculator, let me just make my calculator smaller. If I type this into my calculator, 2.25 times 1.5, cool. My calculator gave me the answer, which is 3.375. But what my calculator doesn't do is it doesn't give me the answer to the right number of Sig Digs. So what I need to do is I need to find my Sig Digs. So this has 3 Sig Digs, this has 2 Sig Digs, and I need to answer to my least accurate measurement. So 2 Sig Digs is my least accurate measurement. So I would want to use, so I underline the first 2 Sig Digs. So 3 and 3 are my first 2 Sig Digs, and then I look at the one after. If it's above 5, I round up. If it's below 5, I don't round up. So I need to round this one up. So the only correct answer for full marks would be 3.4 to the correct number of Sig Digs. Okay. If I did this, Again, I can do this in my calculator. And my calculator will give me an answer, 0.8320 divided by 0.0357. I get my answer, 23.305. 305, dot, 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 a bunch of after that. So I need to find my Sig Digs. So this has 4 Sig Digs. This has 3 Sig Digs. So I need to answer to 3 Sig Digs. So I would do the 3, and I would look at the one after. Well, it's 0, so I don't need to round up. So the correct answer to the correct number of Sig Digs, 23.3 would be the correct answer. Okay. So adding and subtracting is a different set of rules. So with adding and subtracting, using Sig Digs, you want to always round to the number with the fewest numbers after the decimal place. So we don't use Sig Digs for adding and subtracting, we use decimal places. So if I add this up, I don't need a calculator to add this up, it's 168.73. So I need to look at numbers after the decimal place. So this has one number after the decimal place. This has 2 numbers after the decimal place, so I want to round to 1 number after the decimal place. And I'm going to look at my number before it, which is 3. I don't need to round up, so my correct answer would be 168.7. If I did this one, 654.00 would be my answer. This has 2 numbers after the decimal place. This has 0 numbers after the decimal place. So I want to answer 0 numbers after the decimal place. So my answer would be 654 to the correct number of Sig Digs. Okay, so again, let's try some of these board questions. You do them and see if you can get the right answer, and pause the video, and I will do them as well. Okay, so I get 361.505. This is adding and subtracting, so I have 3 numbers after the decimal place. I have 1 number after the decimal place, so I want 1 number. I look at the number before, which is 0, so my correct answer would be 361.5. For this is multiplying and dividing, so I'm going to grab out my calculator for this. 0.86 times 1.15, and this is the answer that it gives me, so 0.989. So now I want to look at Sig Digs. Not significant, this has 2. All 3 of these are significant, I have 3. So I want to answer to 2 Sig Digs. So the 0 is not significant, but these 2 are. I look at the number before, I have to round up. So the correct answer to the right number of Sig Digs would be 0.99. And then this one would be 03.711. So 117.30. If you do this in your calculator though, right, that's where a lot of people get it wrong. So 62.20 plus 55.10. The answer that it gives you is 117.3. But we need to look, okay, 2 numbers after the decimal place, 2 numbers after the decimal place. So it's not actually correct until you have 2 numbers after the decimal place. So 117.30 is the only correct answer. Okay, scientific notation is something that we use quite a bit, so we'll go through how to do scientific notation. Most of the time we're turning standard notation into scientific notation, so I'm going to start with that. So the decimal place is here right now. So what we want, we can keep all these numbers that are numbers and not zeros. So what I want is a number between 1 and 10, 1 and 9.999 really. So 2.543 would be a number between 1 and 10. So if I move the decimal place there, I get that number between 1 and 10. If I move it here, that'd be 25.43. That wouldn't be correct scientific notation. So if I move it here, which I want, I move the decimal place over 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it over 9 spots, so I would go times 10 to the 9. It's a positive 9 because this is a really big number. Okay, for this one down here, if I want to move the decimal place, I can move it here, 0.23, 2.3, 23.4, 234. I want to move it here. because this will get it between a number of 1 and 10. 2.34 is what I want. So I can move the decimal place over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spots. So I go times 10 to the 13. And because this is a really, really, really small number, it ends up being negative. So the way I remember that is if you looked at your bank account and you found this number in here, $2,543,000,000, you would feel very positive. You don't actually put the positive in, but you would feel positive. If you woke up with this in your bank account, you might feel normal because that's what it normally is. Well, but you'd feel negative, right? You have less than a cent in here. That's the way I remember. To do these ones, what we need to do, so this is going to be a really big number. So because I know it's going to be a really big number, I put on that 2.67, and then I put a whole bunch of zeros after it. It doesn't matter how many zeros you put on. So 2.67, I put zeros after it. So I need to move it over 5 spots. So I go 1, 2, 3, 4, 5. So the decimal place will go there. So I need 267 and 3 zeros. So 267, 3 zeros would be my answer. For this one, I know it's a really small number, so I put the zeros before. And I need to move it over 3 spots. 1, 2, 3. And that's where my decimal is going to go. So 0.2 zeros, and then 167. And that's how you do scientific notation. So let's do a board question. So pause the video and see if you can do these on your own. Okay, so this is decimal place here. I move it over 1, 2, 3, 4, 5, 6. 2.32 times 10 to the 6. This one, really small number, so I move it over 1, 2, 3, 4. 2.65 times 10, and because it's small, it's going to be negative 4. This one is a really small number, so I put 2.52, and I'm going to put my zeros before. And I move it over 1, 2, 3, 4, 5, 6. So it's going to be 0 point, and then I have 5 zeros. It's good when you bunch them into 3s. So 5 zeros, and then 4, 5, 2. And this one here is a really big number, so I have 5.999, and a bunch of zeros after. And I move it over 1, 2, 3, 4. So I get 59, 9, 0, 990, like that. So 59,990 would be the correct answer for this one. Okay. Good. Moving on. So Sig Digs in scientific notation. So when a number is in scientific notation, only the numbers before the times 10 to the exponent are significant, right? So how many numbers are significant? Only these ones. So this has 4 Sig Digs. Okay, and if I wanted to answer this to the correct number of Sig Digs, well, I can do that in my calculator. I can go 4.44 times 10 to the 10 divided by 8.8 times 10 to the 3. And I end up getting, this is my answer. So I'd want to answer to the right number of Sig Digs. So this has 3 and this has 2. So I'd only want 2 Sig Digs. So I'd want 5.0, but I'd want 5.0 times 10 to the 1, 2, 3, 4, 5, 6. So times 10 to the 6. Okay. So when to use it and when not to. Scientific notation is a way to make it so big and small numbers are easier to write and read. So scientific notation is not needed for numbers that are less than 100 or numbers that are greater than 0.01. So don't use scientific notation for like 10, 15, 30, 0.1. It's just a waste of time. It's just writing extra things. So let's do a board question. So pause the video, try them, see if you get the right answer. So round all the following to 3 Sig Digs. Well, this one here, 32.0. Don't put that in scientific notation. It's not necessary. This one, right, it's, if I try to do the same thing, it's like 100, 1,000. Well, I can't do that. This is 4 Sig Digs. So the only way to turn this into 3 Sig Digs is to put it in scientific notation. So it'd be 1.00. Now that's 3 Sig Digs, and we move the decimal place over 1, 2, 3 spots. So times 10 to the 3. Now it's in scientific notation. This one here, 1, 2, 3, 4. So 4.5. Make sure you look at this though, right? So these are our 3 Sig Digs. Ooh, we have to round this one up. 4.53 times 10 to the 1, 2, 3, 4, negative 4. Technically, this is the correct answer as well. Because these aren't significant, this is still 3 Sig Digs, but this is a much nicer way of writing it because you don't want a whole bunch of zeros in your answer. It's hard to read and it's ugly and you make mistakes in your calculator. So this is a better answer, but this is technically correct as well. So your calculator and scientific notation. So maybe you were doing this question here and you got it wrong. And the reason why you got it wrong is because you were typing it into your calculator wrong. So when you're typing stuff in your calculator, it's important that you stop doing this and you start doing this. Times 10 to the can all be simplified with this e. Times 10 to the and the e are the same thing. So to do that times 10 to the, you need to push second and you need to push comma. That's what you want. And then that e will show up on the screen. So that's what you use. Why do I need to use that? Well, let's try these two questions. So if I type it in like this, so I type in 4 times 10 to the 13. Firstly, it puts in the divided by up there, so I have to like move it over. There we go. And then I get it on the bottom. And then I type in 8 times 10 to the negative 3. If I type that in and I push enter, this is the answer that it gives me. Okay, let's try that exact same one, but with the e. So if I just go 4, second comma, the e will show up. 4 times 10 to the 13 divided by 8 times 10 to the negative 3. I get a different answer. This is only 1, 2, 3, 4, 5, 6, 7, 8, 9. So you get different answers when typing it in. This one is the correct answer. This one's the wrong answer. So stop doing this because you'll get the wrong answer half the time. Start doing this and you'll have an easier time. It's less to type in. It's easier. You just have to get used to it. So now we're ready for converting between units. This is really important and it's something that students struggle with quite a bit. So you need to follow the steps that I'm giving you because this is the best, easiest way to do it. There are other ways of doing this, but those ways don't work in every situation. So on your data sheet, you have these SI prefixes that are on the back. So these are the steps for converting units. So step 1 is you need to get a conversion factor from your data sheet. Step 2, write the number you are given, what you're trying to convert from, put a time sign and a line beside your number, set up the unit so that the top unit cancels out with the bottom unit, and fill in the numbers from your conversion factor sheet, or the conversion factor that you got in the first step. Those are the steps. If you follow these steps, you will do every one of these correct. If you try your own steps, you're going to get some of them wrong. Okay, so we're going to start off nice and easy, and this is the step that most students screw up. So we're going to get a conversion factor between centimeters and meters. So all we need to do to get a conversion factor is we can put a 1 in front here, find centa, put a meter behind it. 1 centimeter equals 10 to the negative 2 meters. And I don't like just 10 to the negative 2. I put a 1 times in the front so I can use that E button, but timesing anything by 1, 4 times 1, 8 times 1, 12 times 1, it doesn't change the answer. So put a 1 meters behind equals 1 times meters behind. So if I was writing out my conversion factor, I would write out 1 centimeter is equal to 1 times 10 to the negative 2 meters. just like I wrote there. That's it. Let's try it again. Let's get a conversion factor between, what are these? It doesn't matter what these are. Volts, MV, those are megavolts, right? So you find mega, there it is right there. There's mega. And you just go 1 megavolt is equal to 1 times 10 to the 6 volts. So I write that as exactly as it's written. 1 megavolt is equal to 1 times 10 to the 6 volts. That's it. Let's do one more. What the heck is a T? It's a Tesla, but it doesn't make a difference. So we have to find this symbol here. Oh, this symbol here is micro. So let's write it on. So 1 micro, what are we talking about? 1 micro Tesla is equal to 1 times 10 to the negative 6 Teslas. Okay, so we write that out just as I wrote there. 1 micro Tesla is equal to 1 times 10 to the negative 6 Teslas. That's how you get a conversion factor. It's the easiest thing in the world. Just write on your sheet and you'll do fine. So let's do a board question. So I want you to pause the video and try all 3 of these. See if you can get the same answer as me. I'm going to go through them now. Find a conversion factor between a meter and meters. What's an A? Oh, it's an attometer. So I just put 1 attometer is equal to 1 times 10 to the 18 meters. And I write that out. 1 attometer is equal to 1 times 10 to the 18 meters. Volts and kilovolts. Okay, fine. Oh, there's kilo right there. So 1 kilovolt equals 1 times 10 to the 3 volts. 1 kilovolt equals 1 times 10 to the 3 volts. Nano, Tesla, and Tesla. It doesn't matter the order that I give it in, right? I gave the prefix 1 first with this one. I gave the prefix 1 second. I gave the prefix 1 first. It doesn't make a difference. So 1 nano. Where's nano? Oh, there it is. So 1 nano Tesla is equal to 1 times 10 to the negative 9 Teslas. So I write that out. 1 nano Tesla is equal to 1 times 10 to the negative 9 Teslas. That's all. That's all you need to do, and that's a step that most students screw up on. Okay, so let's do an example. So now that we know how to do our conversion factors, we're going to fill in the rest of the steps. So 200 kilovolts to volts. First thing I'm going to do is get my conversion factor. So I got to find kilo. What's kilo? Right here. So 1 kilovolt is equal to 1 times 10 to the 3 volts. And I write that out. 1 kilovolt is equal to 1 times 10 to the 3 volts. That's my first step. So I'm going to switch to my whiteboard here. It's just a little bit easier to write out. So I'm going to write out that conversion factor. 1 kilovolt is equal to 1 times 10 to the 3 volts. Okay. Next thing that I'm going to do is write out the number that's given. So they gave me in the question 200 kilovolts. Then I put a time sign, then I put a line. Before I write any numbers in, I need to make my units cancel out. So whatever you write is always on top. So I want to cancel out units on the bottom with the units that are on top. So kilovolt would cancel out with kilovolts. One's on the bottom and one's on the top. And then volts is what's left over. And then I just look at my conversion factor. There's a 1 beside the kilovolt, a 1 times 10 to the 3 beside the volts, and that's it. So when typing this into my calculator, what I would do is I would type in everything on top in brackets and multiply it. So I would go 200 times 1e3 in brackets, that's everything on top, divided by everything on the bottom, which is 1. Doesn't make a difference, but it will later when we get more complicated. And we get that as our answer. So in the question, we had 3 Sig Digs, so we want to answer to 3 Sig Digs. So this would be 2.00 times 10 to the 1, 2, 3, 4, 5. So my answer would be 2.00 times 10 to the 5, and the units that are left over are volts. And that's my final answer. Okay, let's try another one. So this one here, first thing is conversion factor. So micrometers into meters. So 1 micrometer is equal to 1 times 10 to the negative 6 meters. Cool. Let's write that out to start. One micrometer is equal to 1 times 10 to the negative 6 meters. Conversion factor's got to be your first step. In the question, we were given 300 micrometers. We put a time sign, we put a line. We want micrometers to cancel out and meters to be on the top, so show those canceling out. And then the 1 goes beside the micrometer. The 1 times 10 to the negative 6 goes beside the meters. So typing this into my calculator, I would go on top 300 times 1 e negative 6. And then on the bottom, I have 1.
Mr. Husky, can you please come to the front office? Mr. Husky, front office.
So that's my answer. I want to answer to 3 Sig Digs, so I should answer 3.00, not just 3, times 10 to the negative 4. And my units left over are meters. Okay, we'll do one more. 12 centimeters into meters. So a centimeter is equal to 1 times 10 to the negative 2 meters. So let's write that out to start. One centimeter is equal to 1 times 10 to the negative 2 meters. If you've memorized the conversion, like lots of people know that there's 100 centimeters in 1 meter, that's fine too. Or you can just stick to your chart. Either one will get you the correct answer. Both of those conversions are correct. So in the question, we were given 12 meters. And if we use this one, we want meters on the bottom and centimeters on top, because that will cancel those out. So there's a 1 beside the centimeter and a 1 times 10 to the negative 2 beside the meters, right? You got to keep that consistent. So into my calculator, I would type everything on top multiplied. So 12 times 1 divided by everything on the bottom, which is 1e negative 2. And if I do that, I get 1200, but I want to answer to 2 Sig Digs. So 1.2 times 10 to the 3, and my units left over are centimeters. Right? If you use this conversion, it's the same thing. 12 meters, time sign line. We'd want meters on the bottom, centimeters on top. But this tells us that there's 100 beside the centimeter and a 1 beside the meter. So I'd go 12 times 100, which would get me 1200, which would get me 1.2 times 10 to the 3 centimeters. Centimeters is still left over. So both get you the correct answer. Okay, so let's do some board questions. Okay, so try these 3 on your own, see if you can get it. If not, I will go through them right now, and you can see how I did them. So pause the video. First step, megagrams. So a megagram is equal to, 1 megagram is equal to 1 times 10 to the 6 grams. First thing I'm going to write out. So 1 megagram equals 1 times 10 to the 6 grams. Okay. And in the question, we were given 85 grams, time sign line. I want grams to cancel out, so I'll put grams on the bottom, megagrams on top. There's a 1 beside the megagram. There's a 1 times 10 to the 6 besides the grams. So in my calculator, I would put 85 times 1 divided by, in brackets, always put the top in brackets and the bottom in brackets, 1 times 10 to the 6. And I get to 2 Sig Digs, 8.5 times 10 to the negative 5, and my units left over are megagrams. Okay, let's do the next one. So for the next one, millimeters into meters, so millimeter equals 1 millimeter equals 1 times 10 to the negative 3 meters. So that's what I'm going to start out is with my conversion factor. 1 millimeter equals 1 times 10 to the negative 3 meters. Oh, sorry, going off screen there. 1 times 10 to the negative 3 meters. There we go. In the question, we were given 3.23 millimeters. Time sign line. Millimeters goes on the bottom, meters goes on top, so those will cancel out. There's a 1 beside my millimeter, and a 1 times 10 to the negative 3 besides my meters. Okay, I'm just going to leave that 1 on the bottom because we know dividing by 1 doesn't change your answer. So I'm just going to go 3.23 times 1 e negative 3. Okay, and we end up getting this, so 0.00323. We want to answer to 3 Sig Digs. So technically, this would be correct with meters, or we could say 3.23 times 10 to the negative 3 meters. Both answers would be fine. It's not that small of a number. There's not that many zeros, so both ways of writing it are fine.
Sorry for the interruption, staff. If you are parked in the bus loop at the front by the main doors, could you please move your vehicles to the parking lot?
Okay, last one.
We have 2 large delivery trucks coming right now. Thank
So
you.
nanoliters into liters. A nanoliter. Ooh, sorry, my screen froze for a sec. I don't think it freezes for you guys. Let me just erase the ink. There we go. So a nanoliter equals 10 to the negative 9 liters. So 1 nanoliter equals 1 times 10 to the negative 9 liters. So let's throw that as our conversion factor. 1 nanoliter equals 1 times 10 to the negative 9 liters. And we'll start off with what's given, 982 nanoliters. Nanoliters on bottom to cancel out. There's a 1 beside my nanoliter and a 1 times 10 to the negative 9 beside my liters. And we end up getting, again, I'll just leave the stuff on the bottom out. 982 times 1 times 10 to the negative 9. And I get 9.82 times 10 to the negative 7, and liters is my answer. Okay, that's all. That's how you do it. That's the board questions. Okay, so let's move on. So we're going to do a couple converting between multiple units. And converting between multiple units is the same thing. You just have 2 conversion factors. So I don't know how many centimeters in a kilometer directly, but I do know that there's that many centimeters in that many meters. And I also know that there's in 1 kilometer, 1 kilometer, there's 10 to the 3 meters. So I'm going to write out both those conversion factors. So 1 centimeter is equal to 1 times 10 to the negative 2 meters. And 1 kilometer is equal to 1 times 10 to the 3 meters. Okay, now that I have both conversion factors, I can write out what's given. They gave me 12 centimeters in the question. First thing I want to do is cancel out my centimeters. And I know centimeters and meters, so I'm going to do that as my first step. In 1 centimeter, there's 10 to the negative 2 meters. And then I want to cancel out meters, and I know about kilometers, so I can cancel out my meters. So with my second conversion, in 1 kilometer, there's 1 times 10 to the 3 meters. So typing this into your calculator, same as before, everything on top in brackets. So I'd go 12 times 1e negative 2 times 1. You can leave the 1 out of there because that's not going to make a difference. Divided by, on the bottom I have 1 times 1e 3. Again, you can leave the 1s out there, and I will on the next one. And we get 1.2 times 10 to the negative 4. And our units left over are kilometers. Okay, let's try the next one. 3 meganewtons into femtonewtons. So I'm going to do meganewtons first. 1 meganewton equals 10 to the 6 newtons, and a femtonewton is equal to 1 times 10 to the negative 15 newtons. Sorry, put the x in the wrong spot. So let's write those two conversion factors out. So 1 meganewton equals 1 times 10 to the 6 newtons, and 1 femtonewton is equal to 1 times 10 to the negative 15 newtons. Start off what's given, 3 meganewtons. So I want meganewtons to cancel out first. So I know that there's 1 meganewton and 1 times 10 to the 6 newtons. That cancels out. Put another times sign in another line. I want newtons to cancel out. So femtonewtons goes on top. 1 femtonewton equals 1 times 10 to the negative 15 newtons. Okay, I'm ready to type that into my calculator. What I'm going to type in is 3 times 1 E6. So that's everything on top. I'll leave out those 1s. Divided by, I'll leave out this 1. 1 times 10 to the negative 15. So we end up getting 3 times 10 to the 21. We only have 1 sig dig. So 3 times 10 to the 21. Our units left over are femtonewtons, and that's our final answer. Okay, so that's how you convert multiple units. Okay, so we're going to do a board question. So see if you can do these board questions. Pause the video and I'll go through them now. Okay, so let's go here. So if you look on your data book, it'll tell you that 1 kilometer equals 1 times 10 to the 3 meters. And 1 centimeter equals 1 times 10 to the negative 2 meters. And we are given in the question 4.22 kilometers. Times sign line, kilometers cancel out. So in 1 kilometer, there's 10 to the 3 meters. And then the second step, meters to centimeters. In 1 centimeter, there's 1 times 10 to the negative 2 meters. What I want to type in, 4.22 times 1 E3 divided by 1 E negative 2. Okay, and that's what it gives my answer to the right number of sig digs. It would be 4.22 times 10 to the 345 centimeters. So 4.22 times 10 to the 5. My next one is, so I have microliters, so 1 microliter equals 1 times 10 to the negative 6 liters, and then 1 milliliter equals 1 times 10 to the negative 3 liters. We start off with 5.23 times 10 to the 8 microliters, times sign line. We want microliters on the bottom, liters on top. 1 microliter equals 1 times 10 to the negative 6 liters. And then we want liters on the bottom, milliliters on top. 1 milliliter equals 1 times 10 to the negative 3 liters. In our calculator, we would type 5.23 E8. Oops, we got another thing on top. Times 1 E negative 6 divided by 1 E negative 3. Okay, and that's our answer. We got 3 sig digs, so 5.23 times 10 to the 5 milliliters would be the correct answer. Okay, so last thing we're going to do is convert between multiple units. So these are things where you have kilometers and hours, which aren't exactly the same thing, and we have to convert that. So let's start off with this question. So for doing this, you need a conversion factor for both. And this is a conversion factor that you should memorize because we turn kilometers per hour into meters per second so much. So what you need to know is that there's 1,000 meters in 1 kilometer, and you also need to know that there's 3,600 seconds into 1 hour. So that's something that you should memorize. It just makes it easier because we use it so often. Okay, those are our 2 conversion factors. So we have 200 kilometers. So when doing these questions, lots of people write it like this because that's how it's given in the question, that's how it'll be written, but we don't write it like that. You should only have 1 unit on the top, 1 unit on the bottom. So we write it like this. It's 200 kilometers per 1 hour. Okay, we'll get rid of the hours first. So we'll turn hours into seconds. You see how they cancel out? So we have 3,600 seconds in 1 hour. And then we want to cancel out our kilometers. So I'll put kilometers on the bottom, meters on top. There's 1,000 meters in 1 kilometer. Kilometers cancel out. We have meters on top, seconds on the bottom. So typing this into my calculator, I would do everything on top. I'll exclude the ones. So 200 times 1,000 divided by 3,600. And we get that. We have 3 Sig Digs in the question, so we'd want 55.5, and we want to round that up. So the correct answer to the right number of Sig Digs would be 55.6 meters per second. Okay, let's try another one. So this is a weird one. So say you had a prescription where you're taking 12 grams per day and you wanted to know how many milligrams per year you were taking. Well, we can do that. So what we need is we need a conversion between grams and milligrams. So I can look that up on my data book. So if I look that up here, I would see that a milligram is equal to 10 to the 3 grams. So 1 milligram is equal to 1 times 10 to the negative 3 grams. And then I also need a conversion for days in the year. So I know that there's 365 days in 1 year. Don't worry about the 0.25 unless it's given. Just use 365. Now we're ready to go. We have 12 grams per day, time sign line. So let's get rid of the grams first. So grams into milligrams. 1 milligram equals 1 times 10 to the negative 3 grams. And then we want days up top, years on the bottom. There are 365 days in 1 year. Ready to type that in? (12 times 365 divided by 1e negative 3. We end up getting to 2 Sig Digs, 4.4 times 10 to the 36, and that's milligrams per year. Okay, and then our very last one before the board questions is this one here. We have 12 years to seconds, so this is a little bit of a confusing one. So with this one, time conversions are easier because we already have them in our head. So I'm not going to write out the conversion factor for this one. So we have 12 years. Now what we want to do is we want to convert years into seconds, but we don't know how many seconds are in a year, so we have to take steps along the way. So just like the last one, we know how many days are in a year. We know that there's 365 days in 1 year. So those will cancel out. And then we can go smaller. Well, what's smaller than days? Hours. We know there's 24 hours in 1 day. Days cancel out. And hours, how can we be smaller? All right, we already knew that there's 3,600 seconds in 1 hour. So now we have seconds as our only unit. Now we're ready to rock and roll in our calculator here. So everything's on top, so we just go 12 times 365 times 24 times 3,600. And there's going to be a lot of them, just ones on the bottom, so we'll ignore those. And 2 Sig Digs, we'd want 3.7, round that one up. So it'd be 3.8 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 8 seconds. Okay. So last thing for this lesson is we have two board questions. So I want you to try these. I will do them as well and see if you get the right answer. Okay, make sure you set it up like this. 8 meters per second. Actually, let's write out our conversion factors. We have 1,000 meters in 1 kilometer, and there's 3,600 seconds in 1 hour. Okay, that should just be memorized. 8 meters per 1 second. Meters into kilometers, those cancel out. There's 1,000 meters in 1 kilometer. Seconds into hours, there's 3,600 seconds in 1 hour. Make sure your units left over are kilometers on top, hours on the bottom. So for this one, I would do 8 times 3,600 divided by 1,000. Okay, and you get 28.8. We have 2 Sig Digs in the question, so the right answer would be 29 kilometers per hour. Okay, our next one, we have 8 seconds into years. So we know seconds into hours. There's 3,600 seconds in 1 hour. We know how many hours are in a day. There's 24 hours in 1 day. And we know days into years. We know that there's 365 days in 1 year. So typing this in, all I have on top is 8 seconds on top, and then on the bottom, I have 3,600 times 24 times 365. And that'll give me, to 2 Sig Digs, 2.5 times 10 to the negative 7 years. There we go. And that is it for this lesson. So this is our homework. So Sig Dig questions, scientific notation practice, converting units practice. So let me just go to this. So all the homework is in your workbook here. So if I turn to page 3, you'll notice that there's examples on top. Those have already been done for you. It's these ones that you want to focus on. So you want to do 1, 2, 3, and 4. 3 and 4, and then just ignore those because I didn't assign those. And then on page 6, we have question 1, not example 1, but question 1 is scientific notation practice, and then 2 and 4 will be converting between units. All the answers for these are in the back of the book. So if you turn to the back of the book and you look in Appendix A, all the answers are back there, or they're beside the questions as well. So that's how you can check if you're doing it right. In the review, there are a couple errors. So if you do get something wrong, but it seems right, just let me know, and we will. And it might be just an error in the key. Just in the review, there's one error, and it's kind of annoying. But other than that, the book is good. Okay, thanks for watching.